Now, earlier on, we have studied the some properties of a cross product, and moving on, we are going to look into very simple applications. One of them pertains to the area of a triangle. We are on page 18 of the notes. If you are interested to find the area of a triangle, and this triangle is made up of two vectors, A and B on each side, and of course, there's a third side, right? So if you have a triangle, one side is vector A and the other side is vector B, it can be shown that the area of this triangle, is equal to half the magnitude of A cross B. Now, this can be proven again. We're going to do it in a short while time. That the area of the triangle is half of the magnitude of A cross B. Let me show you the proof. Actually, it's given the notes, but nonetheless, let's do a simple proof. Okay, why should it be that this gives you the area of this triangle? Let's do this arithmetic. A cross B. By definition of cross product, this is modulus A, absolute of the magnitude of A, magnitude of B, sine of the angle between them, and then the vector n cap. Right? By definition, right? By definition, the cross product of A and B is magnitude of A, magnitude of B, sine theta, and then the n cap. Now, because this is a numeral and this is a numeral, I can pull them up. I got magnitude of A, magnitude of B. Now, for angle between two vectors, this angle is at most 180 degrees or at most pi. So if you have to find the sine of an angle that is at most 180 degrees, the sine of the angle is also positive, so I can pull it up readily. So I'm left with the magnitude of n cap. And what is the magnitude of n cap? It's actually 1. So now we have this half magnitude of A, magnitude of B, sine theta. And this is actually the formula that you have learned in earlier years, that the area of a triangle is half the length of one side times the length of the other side times sine of the angle in between them. And why should this formula work that you've learned in lower year is because if you look at this diagram carefully, this angle is theta, and this is actually the height of the triangle. Using your simple trigo, this height is actually, okay, if you use the simple trigo ratio of sine, remember your Picasso, right? H will turn out to be B sine theta. So you can see that actually in your lower years when you learn this formula, half the length of one side, which is this fella, and this one is actually the height of the so-called triangle. So what I've shown you here is half of magnitude of A cross B turns out to be that familiar formula pertaining to the area of a triangle. So therefore, whenever you have to find the area of a triangle, you can just simply find half of the magnitude of A cross B, provided A and B are two adjacent sides of a triangle. Now, if this is the area of a triangle, can you tell me if I have to find the area of this parallelogram? If I have to find the area of this parallelogram, what do you think it will be? I'm sure it won't be long for you to realize that this area is just magnitude of A cross B. Simple as that. Okay. Now, so with these two, let us move on to example 4 and example 5. Let's do example 4. We are now on page 110. Page 110, example 4. Example 4 on page 110. Okay, let me write page like this. Page 110. Right. So in this question, you are given three vectors or 3 points, rather 3 points, A, B, and C. So the 3 points, maybe you can draw them as like this. A, B, and C. And now in this question, right, you are interested to find this area. So to find this area, based on what you have just learned over here, how would you think you can find the area of this triangle? So if you compare this diagram with this vector AB is like the vector A, and this vector AC is like the vector B. So to find the area of this triangle is actually half of AB cross AC and then the magnitude. So this will give you half. Okay, the vector AB. How do you find the vector AB? You're given the question that A is 2, 3 minus 2, B is 1, 1, 1. So the vector AB will be OB minus OA. So the vector AB would be minus 1, minus 2, 3. And the vector AC, right? AC will be OC minus OA. That will give you will give you 1 minus 5, 4. Okay, and then you have to perform the cross product of these two vectors. If you perform the cross product of these two vectors, what do you think you get? Okay, remember the alternative way that we learned. How do we find the cross product of two vectors in the alternative way? What we do is we cover the first row, this times this minus this times this. So I got minus 8 plus 15. So I got 7. You cover the second row. You have minus 4 minus 3. Minus 4 minus 3. Minus 4 minus 3 is minus 7. And because middle need extra minus. And then lastly, you have 5 minus 2, you get another 7. And then you have to find the magnitude of 777, and this in the end works out to be 7 root 3 over 2. Right, so this is how you find the area of a triangle in example 4. Let's do example 5. Okay, look with me to example 5. Example 5. Okay, in example 5, you are given 3 points P, Q, R, and then there's a 4th point that forms a parallelogram. P, Q, R, S. Right, I hope my parallelogram looks good. Okay, I think let me polish up this a bit. Right, in this question, you are interested in a parallelogram. You are given 3 points. You are given P, Q, and R. So you know this three, right? P, Q, and R. Right, you know these 3 points, and you are asked to find the point S. In a parallelogram, it is known that the midpoint of PR and the midpoint of QS are the same. So if the two midpoints are the same, we can make use of this fact to actually try to find the point S. But firstly, how do you find the midpoint of 2 points? What is the midpoint of PR? The midpoint of PR would be what? The midpoint of PR would be OP plus, wait, maybe I should write here. Okay, OP plus OR divided by 2. This is the midpoint of PR, and then the midpoint of QS OQ plus OS divided by 2. So by so doing, you can then realize that OS, right, the vector OS or the point S with position vector OS is just OP plus OR minus OQ. And then immediately, in this case, right, if you do your calculation correctly, you ought to get the column vector 1, 1, 1. By just typing in OP, OR, and OQ, you can find the point or the position vector of the point S, which is OS. Right, then in this same question, you want to find the area of this parallelogram. Area. How would you find the area of this parallelogram? You can actually take the two vectors. Okay, you can take this vector PQ and PS. Right? You can find the area of this parallelogram by doing this. Remember, you compare with this diagram. PQ is like the vector A and PS is like the vector B. And to find the area of this parallelogram will be the vector PQ cross the vector PS. Right? You just half of this. And if you do your calculation of the cross product correctly, you should get the answer for this, right? The answer for this will turn out to be 7 square root 3, right? So in this section, you have learned just very simple application of the cross product, and we have applied these applications to example 4 and example 5.